On videos A and B, we talked about greatest common factor, and we focused on two different processes in order to find the greatest common factor. You could list factors, find the common ones, and then find the greatest of those common ones. And then we can also use the prime factorization method, where we're factorizing all of the numbers into their prime factors and then multiplying common prime factors. You said that we find greatest common factor in word problems when there's words like greatest in the question, or most, or largest. And also, a lot of times, greatest common factor questions are when we're asking about how many groups can be made, like teams, like in the example yesterday. Now today, in this part C video, I want to talk about how we can use greatest common factor to rewrite some expressions. We're going to go all the way to station 4. We're going to use the greatest common factor and the distributive property to change these particular problems into another equivalent expression. Equivalent meaning equal expression. So if we look at the first one, 12 and 18, many of us can do that in our heads. And we say, well, that equals 30. But what we want to do is prepare you for algebra in the future. And many times in the algebra, what you do is you change one expression into another one that might be easier to use. So we're going to rewrite this particular 12 plus 18 as a new expression. What we're going to first do is find the greatest common factor of both 12 and 18. And I'm going to use the prime factorization method. 12 breaks into 3 times 4. 3 is prime, and 4 can break into 2 times 2, which are both prime. 18 is 2 times 9. 2 is prime, but 9 can be broken into 3 times 3, which are both prime. Now, if I use my Venn diagram, the left circle represents 12, and the right circle represents 18. They have a 3 in common, so I'm going to put that in the center. And they have a 2 in common, so I'll put that in the center. 12 has a 2, but not 18. And 18 has a 3, but not a 2. And then if I multiply the two prime factors that are shared, I can see that the greatest common factor is 6. So I'm going to put that greatest common factor, I'm going to rewrite this expression by putting the greatest common factor out front of a set of parentheses. Then I'm going to, inside the parentheses, take the factors that are left of 12 and 18. Well, if I factor out a 6, what's left of the 12 is the factor 2. I want to separate that with a plus sign, and then I'm going to write the factors that are left of 18. What's left of 18 when I factor out a 6 is a 3. So the expression 12 plus 18 is equivalent to the expression 6 parenthesis 2 plus 3. We can prove this by using order of operations. We would do what's in the parentheses first. 2 plus 3 is 5. And then we would multiply it by 6 and get 30. And that's the same amount that we got for 12 plus 18 originally. All we're doing is writing an equivalent expression to those that are listed. Now I'll do one more with you. I'll do the next one, but the remaining of these problems I'm going to have you guys do for homework. Let's write an equivalent expression to 42 plus 14. Let's factor 42 and 14 into its prime factors. Pause the video, try it yourself, and then hit play and see if you did it correctly. I'm going to factor 42 into 6 times 7. 7's prime. 6 can be factored into 3 times 2, which are both prime. 14 is 2 times 7, which is both prime. I make my Venn diagram for the numbers, and I can see that 42 has a 3, but 14 doesn't. They share a 2, and they also share a 7. Multiply what they share, I can see that the greatest common factor is 14. So I'm going to put that in front of the parentheses. What's left of 42 when I factor out the 14? Just the factor 3. And what's left of 14 when I factor out a 14? Well, there's no other numbers on that 14 circle, but I can't say 0 because 0 is not a factor of 14. Whenever there's nothing there, it's an understood 1 as a factor. So we can say that the expression 42 plus 14 is equivalent to 14, parenthesis, 3 plus 1. And I can prove it. I can add these together and get 56. And over here on the right, I can use order of operations. I would do that first. I get 4 for 3 plus 1. And then multiply it by 14, and I get 56. Which proves that this expression is equivalent to this expression.